All right, to solve this system, the technique we're going to use, we're going to introduce a couple of new variables into this little system of equations. What we're going to do off the side here is we're going to introduce a variable a. We're going to let that variable a equal 1 over x. We're also going to introduce a variable b. We're going to let that equal 1 over y. Now, if we do that, how we can now tinker with our system, we can rewrite this first equation in the system where we can take out this over x idea, this 12 over x idea, and simply write it as 12a. And the reason we can do that, if a is 1 over x, this would be 12 times 1 over x. What is 12 times 1 over x? It's 12 over x, right? So in the same manner, I can take this 5 over y, rewrite it as 5b. If b stands for 1 over y, I take 1 over y, multiply to 5. That's the same thing as 5 over y, right? That's all going to equal 25. If I make the same adjustment now to the second equation, since this is 2 over x, I'll write 2a minus, since this is 15 over y, I'll write 15b, and that will equal negative 18. Now we've got a system that'll be a little easier to work with. And in terms of a process you want to use from this point on, it's really up to you. I'm usually a fan of elimination, so that's what I'm going to use. In fact, I'm going to eliminate the b's. To eliminate the b's, I could take this first equation. I could multiply it by 3, right? That would give me a 15 here, a negative 15 there. Be easy to cancel out. All right, so if I transfer down here, multiplying that 3 through the top equation, you've got 36a plus 15b equals 3 times 25, 75. Second equation is staying as is. All right, if I add through now, with the a's, we're going to have 38 of those. The b's, the idea is they should cancel out. We got 75 minus 18, which is 57. That's wonderful, isn't it? Divide through by 38. And a is going to equal 57 over 38. Fantastic. Let's see, is that going to reduce? That's not going to reduce. What's it reduce to?
Oh, wait. I don't know. Yeah, it's 3 halves. I was going to say.
Yeah, 19 goes into both, doesn't it?
You divide it and it goes.
Yeah, 19 goes in. Good. So a is 3 halves.
I use my
All right, so we've got what a is. We could go ahead and figure out what b is using one of our new equations we create over here. You know, maybe if we plug back into the first one, it doesn't matter. If I plug back into the first one, I know a is 3 halves, so it'd be 12 times 3 halves plus 5b equals 25. This is 12 over 1, so that's going to be 36 over 2, which is going to be 18. You got 18 plus 5b equals 25. So 5b will equal, subtract 18, that's going to be 7. b is going to equal 7/5. Now ultimately we're trying to find this ordered pair to solve the original system. The original system, we've got x's and y's we need to find. So now what I'm going to do, since I know a is 3 halves, I'm going to go over here, take this a out, put 3/2 in its place. That'll give me an equation to solve for x, right? And with this b equals 1 over y, I can take that b out, replace that with 7/5. That will give me an equation to solve for y. So if I do a little cross multiplying here, we're going to have, let's see, 3x equals 2, right? So x is going to be 2/3. I'm trying to create an ordered pair as a solution. Let me set it up right here with the limited space I got. X coordinates 2/3. And for the other proportion we got there to solve for y, if I cross multiply, we're going to have 7y equals 5, so y is going to equal 5/7, right? Well, and that's the observation to make here. Yeah, if you've got 1 over x, you've got 1 over y. Basically, what you get for a and b respectively there, it's going to be the reciprocal. That will always happen if it's a 1 over that variable relationship. So yeah, I take away that observation because that's going to save you the time and having to go through this process to solve. So our ordered pair is 2/3 and 5/7. That's our solution to the system.
I'm not a dog.
If we're going to solve this one, thinking of all the strategies that we've used before, out of those strategies, elimination has worked pretty well for us. And if I'm trying to solve for x and y here, it seems like it's set up pretty reasonable to solve for the x's to start, right? You can eliminate the y's. So to eliminate the y's, I just pick one equation and multiply by -1, right? And if I pick, say, the second equation and I multiply by -1, all that's going to do is change the signs. So let me do this. That'd be convenient, right? If you add through, now let's see what happens. With the x's, we've got ax minus bx, right? The y's go away, and that equals b minus a. Only the x's remain, so I can solve for x. What should I do here to solve for x? Any ideas? Okay, you're going to divide by a minus b, and why is that? What step could I show to justify dividing by a minus b? What can I take out of these two terms? X is in common, right? So take an x out. If you take an x out, a minus b is left. That equals b minus a. So this justifies dividing both sides by a minus b. X is going to equal b minus a over a minus b. Now we could do better than that. Any ideas what b minus a over a minus b actually gives you? Not 0. Almost, not quite, 1. Actually gives you -1. So, to make sense of that, pick a number for a, pick a number for b, and plug in. Say that a is 5 and b is 3. If you do that, you've got 3 minus 5 over 5 minus 3, right? So up here we get -2, down here we get +2. The thing is, you're always going to end up with opposite results that you're dividing, and if you have opposite results that you're dividing, you get a -1 back. So x is -1, building an answer that is the ordered pair. We've got the x coordinate. And since we have the x coordinate, we can go back to the equations that were given. We can plug in x to solve for y. So say I take this first equation right here, plug in -1 for x to solve for y. Let's see, what does that give me? That gives me a times -1 plus y equals b. So this is going to be negative a, right? Negative a you're going to add over. If you add over, y is going to equal b plus a. And there's not much you can do about that, right? It's just b plus a. So the rest of the ordered pair up here, we include that y coordinate. That y coordinate's b plus a. There's your solution.